All right, in summer homework problem number 18, there's a system of equations. And there was another video on system of equations, but it involves substitution. In this case, we don't want to use substitution because we don't know what either x or y is equal to, so we have nothing to substitute. In this case, we want to use a different technique. And here we're going to use a technique called elimination. You can tell you want to use elimination when the x's are lined up with the y's and the constants. You could solve this using other methods. It would just take longer. This is a difficult system of equations as far as they go because there isn't anything easy to eliminate. The way elimination generally works is you have something like 2x plus y equals something and negative 2x plus 4y equals something, and you add the two equations together, and one of the variables ends up canceling out. 2x plus negative 2x will give you no x's, and so you end up with just y's, or end up with just x's. In this case, if we added the two equations together, nothing would eliminate. We would end up with 1x and negative 12y's. We'd still have both x's and y's. So the idea is to multiply both sides of the equation by a certain number to make it so that something will cancel out. There's nothing you can multiply 2 by to get to 3, and there's nothing you can multiply 5 by to get to 7, no whole numbers at least. And so what we'll do is we'll find the least common multiple, either of the x's or the y's. They would both work. If we do it with the x's, 6 is the least common multiple, and I want one to be negative and one to be positive, which they already are. The way this works is I will multiply both sides of the equation, in the top one by 3, and both sides of the equation in the bottom equation by 2, and the x's will then have 6 x's in both. Let's see how that works. I'm going to multiply the whole equation by 3. So I'm allowed to do this because I'm keeping it balanced. The left side and the right side are both being multiplied by 3. Negative 6x minus 21y equals 51. That's this first equation, just multiplied by 3. It's still a true equation. In the bottom equation, again, I'm trying to get to 6. So 2 times 3 is 6. 3 times 2 is 6. So I'm going to multiply this equation by 2. So this will say 6x minus 10y equals negative 20. I multiplied both sides of the equation to keep it balanced. And now, since the x's line up, I can add the two equations together. And this works because if you have a true equation, both sides are equal, and another true equation where both sides are equal, adding them together, the two sides will still be equal. And when we add together, we get negative 31y equals 31. Notice that the x's canceled out. That was the whole point, was to just get y's. And we can divide both sides by negative 31 to get y is negative 1. Now this is only part of the solution. We still need to get what x is equal to, and so we need to plug in y into either one of these equations. If I plug in y into this first equation, I could have also plugged it in the second one. I will get, let's see, I'm going to write it over here. So I'm plugging in y is negative 1. I'm substituting for y. So negative 2x minus 7, and then instead of y, we're going to put what y is equal to. Y is negative 1, so we're going to put that in, equals 17. And we're going to solve for x. Negative 7 times negative 1 is positive 7. And we're going to subtract 7 on both sides. I'm not going to show that step, because I'd rather show you something else in just a second. We're going to divide by negative 2. And we get our solution. Again, we can write this as x comma y if we would like. The x goes first. This is also an acceptable way to write the solution. I could have solved this problem very differently by instead trying to eliminate the y's. And what this would look like is I'd want to get a least common multiple that the y's would cancel out to make. And the least common multiple between 5 and 7 is 35. And so what I would have done here is I would have multiplied the top equation by 5, and I would have gotten negative 10x minus 35y equals 85. But the bottom equation I wouldn't just multiply by 7, because both the x's and the y's would be, or both of the two equations would have a negative 35y. And so I would multiply this one by negative 7. That way I would have negative 35y, and it would cancel out with positive 35y. And sometimes this happens, so I just wanted to make sure you had seen this. I'm multiplying by negative 7 to make it be positive 35y. That way, the actual, equals 70. That way, the y's will cancel out. And I don't think I'm going to go ahead and solve this all the way, but I will add these together and see that this is 155, and dividing both sides by negative 31 gives you x is negative 5. So notice we've gotten that same part of the answer that we had before. We would then take the negative 5, plug it in for x to figure out what y is. Hopefully that helps.